Temporal indices and chronos maintain time-ordered references to data records across storage tiers. The system stores metadata about record timestamps, validity intervals, and archive status within a dedicated B-tree structure. Retention policies define how long records remain accessible in hot storage before transitioning to cold archive. Default retention period is 90 days. Records older than the configured threshold are marked for archival but remain queryable through the archive interface. The retention configuration block accepts 3 parameters: retention days, archive tier, and cascade delete enabled. The retention days parameter accepts integers from 1 to 3650. Archive tier specifies the target storage backend, typically S3 or Glacier. When cascade delete enabled is set to false, archived records remain queryable indefinitely. The default configuration maintains records for 90 days in primary storage with subsequent migration to cold tier. Archive transition occurs during scheduled maintenance windows, typically at 2:00 UTC daily. The system identifies candidate records by comparing current timestamp against retention days threshold. Records are sorted by timestamp and transferred in batches of 10,000 records. Transfer rate is throttled to maintain system stability. Batch status is logged to the archival event stream for audit purposes. The temporal index maintains validity intervals for each record. Validity intervals are defined by start time and end time fields stored as Unix milliseconds. A record is considered valid if the query timestamp falls within its validity interval. The system automatically computes these intervals during write operations. Overlapping validity intervals are permitted and do not trigger validation errors. Query performance against archived records follows the same execution path as hot storage queries. The archive interface transparently handles data locality. When a query references data outside the retention window, the system checks archive metadata first. If archive data exists, the query is routed to the cold storage backend. Response latency increases proportionally with archive depth. Temporal index fragmentation occurs when validity intervals are frequently updated or when records are deleted from middle regions of the timeline. Fragmentation increases lookup cost by requiring additional B-tree traversals. The defragmentation process compacts validity intervals by rewriting affected index pages. Defragmentation runs weekly by default or on demand via the maintenance API. The archival manifest maintains checksums and metadata for each archived segment. Manifests are stored in a separate index structure alongside the primary temporal index. When records are archived, the system computes SHA-256 checksum of the segment. Checksums are verified during archive retrieval to detect data corruption. Failed verification triggers an error log entry and archive repair procedure. Cascade deletion is controlled by the cascade delete enabled flag in the retention policy. When enabled, records exceeding the retention threshold are permanently deleted from all storage tiers after a 14-day grace period. The grace period allows recovery from accidental deletion. During grace period, records are marked as deleted but remain retrievable. After grace period expiration, deletion is irreversible. Temporal range queries execute against the index using interval tree algorithms. The query specifies a start time and end time parameter. The system traverses the B-tree to locate records whose validity intervals overlap with the query range. Result sets are returned in ascending timestamp order. Query execution time is logarithmic in the number of records. Archive storage tiers are configured through the storage backend section of the system configuration. S3 backend requires AWS credentials and bucket configuration. Glacier backend is recommended for deep archive scenarios with infrequent access. Azure Blob Storage is also supported as a tier option. Archive tier selection does not affect query interface. Queries remain uniform regardless of storage backend. The temporal index supports time series aggregation functions, sum, average, minimum, maximum, and percentile calculations. These functions operate on records within specified time windows. Aggregation queries are optimized through pre-computed summary statistics stored within the index structure. Summary statistics are updated incrementally as new records are written. Aggregation queries execute in constant time. Temporal index snapshots are created during checkpoint operations. Snapshots capture the complete state of validity intervals and archive metadata at a specific moment. Snapshot files are serialized using the same format as transaction logs. Snapshots are stored on persistent storage alongside the primary index. Recovery from system failure restores the index to the most recent snapshot state. Multi-version timestamp validation ensures that queries referencing past versions of records retrieve the correct temporal state. The system maintains version vectors for each record. Version vectors contain timestamps for every update operation. Queries specify a version parameter to retrieve records as they existed at a specific point in time. Version-aware queries include all intermediate validity intervals. Clock skew handling accommodates small discrepancies in system clocks across distributed nodes. The temporal index allows a maximum clock skew tolerance of 5 seconds by default. Records with timestamps within the skew window are ordered using vector clocks as a secondary ordering mechanism. Clock skew greater than the tolerance threshold triggers a warning log entry and deferred consistency resolution. Index maintenance operations include vacuum and optimize procedures. Vacuum removes deleted records from index pages and reclaims disk space. Optimize rebuilds the index tree to improve balance and reduce traversal depth. Both operations are non-blocking and execute incrementally in background threads. Progress is tracked through the Maintenance Status API. Vacuum defaults to weekly execution. Temporal index monitoring exposes metrics through standard Prometheus endpoints. Metrics include record count, average validity interval length, archive size, and query latency percentiles. Alerting rules trigger notifications when archive growth exceeds configured thresholds or when query latency increases above baseline. The monitoring system stores metric history for trend analysis and capacity planning.